So next we were the definition. Let A, B, and N are integers, and N is greater than 0. We write A is congruent to B mod N if and only if N divides A minus B. N is called the modulus, B is called the remainder. So for example, 29 is congruent to 15 mod 7 because 29 minus 15 is equal to 14. And if we're going to divide it by 7, the answer is 2. And that is a whole number. Okay? 12 minus 3, the answer is 9. Mode 9. Okay? So 9 divided by 9, the answer is 1. Also, 3 is a valid remainder since 9 is equal to divides 12 minus 3. If we're going to divide it, the result is 9 divided by 3, the answer is 3 pa rin po siya. And that is a whole number. 12 minus 21, mode 9. So, counterclockwise direction po tayo. Kasi negative po siya, no? Negative 12 minus 21, the answer is 9. Pareho pa rin, 21 is a valid remainder since 9 is divides 12 minus 21. And for the last one, 12 is congruent to negative 6, mode 9. Negative 6 is also a valid remainder since 9 divides negative 6 minus 3, that is 1. Okay? If we're going to subtract 12 minus 6, magiging 12 plus 6, that is 18. 18 divided by 9, the answer is 2. That is a whole number. So next we have now the arithmetic operations of modulo n. Properties of addition in modular arithmetic. Number 1, if A plus B is equal to C, then A mod n plus B mod n is equal to congruence to C mod n. If A is congruent to B mod n, then A plus K is equal to congruence to B plus K, where your K is constant mod n. For any integer, K po siya. If A is congruent to B mod n, and C is congruent to D mod n, then A plus C is equal to B plus D mod n. Thus, if A is congruent to B mod n, then negative A is congruent to negative B mod n po siya. Okay? So, next. Example. It is currently 7 p.m. What time in AM or PM will it be 1000 hours? Sabi dito, time repeats every 24 hours. Umiikot po, no, yung relo po natin. So, we work modulo 24. Since 1000 is equal to 16 plus quantity 24 times 41 is congruent to 16. So, dito ginamit natin yung formula dito sa pangalawa. Okay? If A is congruent to B mod n, then A plus K is equal to B plus K mod n for any integers K, no? So, dito, paano nakuha yung 24 times 41? We're going to multiply 24 times 41. We're going to give you 984. Kasi pag 24 times 42, that is more than 1,000 na po yun. So, hindi na siya pwede. Kailangan po natin yung may remainder. So, 24 times 41, that is 984. 984 plus 16, the answer is 1,000. So, they are congruent, which means this is your remainder. So, it's congruent to 16 mod 24. So, therefore, the time in 1000 hours is equivalent to the time in 1600 hours. Therefore, it will be 11 a.m. in 1000 hours. So, that is 7 p.m. plus 12 magiging 7 a.m. 12 plus 4 hours, because we're referring here 16 hours, kaya naging 11 p.m. po siya. Next, we have your find the sum of 31 and 148 in Modulo 24. Solution number 1, 31 in Modulo 24 is equivalent to 7. Because 31 minus 24, the answer is 7. If we use the first modular addition rule, we find that 31 plus 148 is congruent to 7 plus 148, which is equivalent to 155 mode 24. Okay? Then 7 plus 148, that is 155. And also, 155 in modulo 24 is 11. So, paano nakuha yung 11? Because if we're going to multiply 24 times 6, the answer is 144. Kasi pag 24 times 7, it's already more than 155. Hindi po siya pwede. So we have 6 times 24, we have 144. 155 minus 144, the answer is 11. Okay? Another solution. As stated previously, 31 in modulo 24 is 7. Ito po yung remainder, no? 31 minus 24, the answer is 7. Instead of using the first rule, we'll use the second rule, that 148 is 4 in modulo 24. So, paano naging 4 siya? Okay? So, 6 times 24, we have 144. 148 minus 144, the answer is 4. So, now, all we need to find is 7 for this one, the difference in remainder, plus another remainder 4, the answer is the same as 11. Okay? Next, find the remainder when 1, 2, 3, 2, 3, 4, 32, 56, 22, 12, and 78 divided by 3. So we know that 1, 2, 3 is equal to 0. Paano naging 0 po siya? Congruence to 0. 1 plus 2 is 3 plus 3 is 6. 6 divided by 3, the answer is a whole number or an integer. That is 2. So wala tayong remainder. So we have 0. Mode 3, no? 2, 3, 4. 2 plus 3 is 5 plus 4 is 9 divided by 3. No remainder. Mode 3. 3 plus 2, the answer is 5. 5 minus 3, the remainder is 2. Mode 3. 5 plus 6 is 11. 11 minus 9, the remainder is 2. Next, we have 2, 2. We have 4 minus 3, the answer is 1. Mode 3. 1 plus 2, that is 3 divided by 3, the answer is 1. No remainder. 7 plus 8 is 15 divided by 3, 5, no remainder. Mode 3. From the property 3, we have 1, 2, 3, plus 2, 3, 4, plus 32, plus 56, 22, plus 12, plus 78. The answers are, or remainder, we have 0, 0, 2, 2, 1, 0, 0. If we're going to sum it up, we have now a total of 5 mode 3. So since 5 as a remainder of 2, when we divide it by 3, so that's 1, 2, 3, 2, 3, 4, 32, 56, 22, 12, and 78 has an answer of 2. So that is our remainder. If we're going to add these numbers, add divisible by 3. So that's our answer. Next, we have your D multiplication. The properties of multiplication in modular arithmetic. If A times B is equal to C, then A mod N multiplied by B mod N is equal to congruence to C mod N. If A is congruence to B mod N, then K times A is congruence to K times B mod N for any integer K. If A is congruent to B, mode N, and C is congruent to D, mode N, then AC is congruent to BD, mode N. Okay? So this is our example. What is 8 times 16 mode 7? So 8 minus 7, the remainder is 1. Mode 7. 16 divided by 7 is 14, no? 16, 7 times 2 is 14. 16 minus 14, we have a remainder of 2 at mode 7. So therefore, 8 times 16 is equal to 1 times 2 congruence 2, 2 at mode 7. So that's our product. Okay? Next, find the remainder when 1, 2, 4, 1, 3, 4, 23, 49 to 3, 5, 13 is divided by 3. We did a similar problem above where the signs were all positive or plus instead of x. In that case, manually adding the numbers up wouldn't take that much, though the modular arithmetic solutions was faster. In this example, multiplying the numbers would be tedious. Instead, we use property 3 repeatedly. We know that 1, 2, 4, okay, 1 plus 2 is 3 plus 4 is 7. 7 minus 6, the remainder is 1. 1 plus 3 is 4 plus 4 is 8 minus 6, the remainder is 2. 2 plus 3 is 5 minus 3, remainder is 2. 4 and 9 is 13 minus 12, remainder is 1. 2, 3, 5 is 10, remainder 1. And 13 minus 12, remainder 1. Therefore, 1, 2, 4, 1, 3, 4, 23, 49, 2, 3, 5, 13 is congruent to 1, 2, 2, 1, 1, 1. If we're going to multiply this one, the remainders, the results are 4, which is 4 minus 3, the remainder is 1 at mode 3. Implying the product upon division by 3 leaves a remainder of 1. So that's our answer. Thank you. That ends our week 13.